Hello everybody and welcome to the Charleston Power BI User Group. This is actually our second meeting, so I'm super excited about that. Being the second meeting, let me make sure I mute there. Being the second meeting, we're going to do something a little bit different in our chapter. Our chapter is pretty small, so we're only going to meet in person once a quarter, and 2 months out of the quarter, we're going to do a virtual meeting. Fortunately, I have some amazing friends like who we're going to hear from today. So I welcome everybody who is coming along. I see a couple of people. People are just now starting to tap in now. I see a couple of our user group people, one of them being one of our leaders, Rhett Cipher on. Hi, Rhett. Hi, Corey. And welcome everybody else. And I appreciate you attending. Just a little bit about our user group. Got to get a little bit of user group business in before we get to the main topic today, or what we're all here to see. First of all, I want to point out, if you're not a user group member, it's free to join. I strongly encourage you to join. It's PBIUGgroup.com, and feel free to join the Charleston Power BI User Group chapter. That way you'll make sure you hear about our group's activity. So again, we're going to have some pretty amazing topics and speakers coming up. I'm super excited about that. Also, on the right side of the screen, you can see we have some Power Platform Summits. Now, on the screen, one of them has already happened, Amsterdam. Australia is happening in August. And in North America here in October, we're all going to go visit Mickey at Disneyland in Orlando. I'll be there at Orlando. Reza, we were just talking, he's going to be there as well. He's got some classes, so we'll ask him about which classes he's doing when we get there. I'm going to be doing 2 pre-con classes. One of them is an introduction. It's a partial introduction to Power BI. It's going to be the first 2 belts in the Power BI User Group Black Belt series. And I'm also doing a half-day class on financials in Power BI, so I'm excited about that. Before we ask Reza what he's doing, I do want to point out the next few meetings that we have. Oh, yay, hey, Reda's on too, our other chapter leader. Hey! So upcoming in July, we're going to do another virtual one. I hope everybody comes and attends to that. It's going to be SharePoint MVP and very dear friend of mine, Christina Willer. So she is like brilliant. She's a developer, so I adore her. In August, we're going to hopefully be having our in-person meeting, and we're lucky enough to have Jason Tremper from the Microsoft Platform team. He is a Charleston area resident and a good friend of ours, so he works on the pagination team, so that should be interesting if you happen to be in the Charleston area. It's worth a trip. It's actually very, very beautiful. And so I'm super lucky. I'm going to first introduce him, and then I'm going to ask him what he's doing at Summit. I am so lucky that I have friends that I just respect and adore so much, like Reza Rad from Radicad, all the way speaking to us from New Zealand, and it's a tough week for him too, because he just flew home from the States. He was at the Microsoft Business Application Summit last week, and then flew all the way home. He probably could have flown around the world because it's on the other side of the world for us, and yet he's still coming to speak to us today. Hi, Reza.
Hi, Belinda. How are you doing?
Yeah. So what classes are you teaching pre-Summit?
Summit was really fantastic. It was like a week, let's say, full of activities. It was a long trip for me and Leila, but it was like a long trip in a short amount of time. Our body even didn't have time to like feel the jet lag, because we just went there, do the summit, do all like a few single sentences before and after, and then came back. It was like super exciting announcement over there.
Cool, cool. And you're going to be at the Power Platform Summit in Orlando as well, right?
Yes, yeah, looking forward to it. That's, I think, the week of 14th of October. I'm doing a Power BI architecture workshop, so nothing related to this topic today, because today's topic is about like building reports, building the model. That is more about architecture of how it connects Power BI with all other components, what is different types of connections, what is the preferred way of sharing, licensing, all sorts of things. And Leila is doing one on AI and Power Platform, something similar to what she did in MBAS, which is one of the most popular pre-cons with like about 200 people in it. So
yeah,
really excited, looking forward to that.
A friend of mine was in your session, and we went to dinner Sunday night. He was in your full day class Sunday, and we sat next to each other, and he told me, he talked nonstop about it all through dinner. So it was a really good session. And one of the viewers and one of our chapter members, Corey Turner, he actually wrote Reza and Leila's sessions at MBAS were great as usual. So very, very cool. I'm going to go ahead and make you presenter. For those of you who are wondering, should you go to Summit, the answer is yes. It is huge, but there's a lot going on, and part of it is being able to see people like Reza Rad in person, which is always a joy. I wish I could be a fly in the wall, on the wall in your class listening in. That would be fun. Okay, so do you see the control to share your screen?
Yeah, I'm trying to find it now. Okay, display one. Okay. That's the one.
There we go.
Okay, I'll bring my slide here.
I see your desktop. Yay!
Yeah, my desktop is full of Power BI things.
And so for, the popping sound probably is my mic. I'll mute myself right now. If you guys have questions, go ahead and just ask them. I will unmute at the time I see them, and we'll ask Greta. On YouTube Live, there is like a minute or so delay, so don't think that I'm ignoring you right away. So meanwhile, I'm going to go ahead and mute, and Greta, the floor is all yours.
Okay, great. Thank you. Thank you everyone for watching it live, and everyone who will be probably watching it later on. Thanks, Belinda, for the opportunity. I really appreciate that. And let's go through the session itself. So in this session today, I'm going to talk about basics of Power BI modeling, nothing, let's say, super advanced tactics or writing complex DAX calculations, getting the basics right, because based on my experience, I have found a lot of models suffers from not having the right basics. So let's get that fixed, and then if needed, we can do like sessions afterwards on like more advanced topics. A little bit about me. If you don't know about me, I'm Reza Rad. I'm a consultant and trainer on Power BI topics. I'm based in New Zealand, Auckland. I'm living usually in tomorrow, so right now, which is probably 19th for you, it's 20th here already. It's 10 a.m. And I'm author of some Power BI books. One of them is focused on architecture, Power BI Pro architecture. Another set is like 4 books already itself, and talks about different parts of different parts of Power BI, like essentials, getting data and transforming it, DAX and modeling, and then visualizations, all different parts of it. You can get the book that I mentioned from our website, so you can connect to Radicat website, you'll get the book. My contact information is also available there, so feel free to reach me if you have any questions. Okay, so let's jump into the topic today, what I'm going to talk about. So it's pretty simple agenda. I'm going to show you first what is a bad data model and why it is a bad data model, because just saying that this is a bad data model is probably not enough. You might want to know why this model doesn't work, that we call it a bad data model. Then after that, you know that this is a bad data model, we'll talk about, okay, what is a good model, and what we can do to, let's say, fix that bad model, or let's say convert that bad model to a good data model, right? That would be through like an example and few slides. So let's go through that, right? I'll start simple. So let's say I'm doing a Power BI report on analyzing manufacturing data, right? I have a data table, has manufacturer data in it, manufacturing data, like which product at which date, and some information about that. And I'm going to build a report on that to see what Power BI can do for me, and then I'll add some more stuff to that, right? So I have a Power BI desktop here. Hopefully you already worked with Power BI desktop. Then I start getting data from a data source. My data source is an Excel data source. In this Excel data source, I have a number of tables. One of these tables is manufacturing data. Now let me also enable zooming so you can also see this a little bit bigger. Okay, so this is manufacturing data. It has like the date of manufacturing, the product, and the cost of manufacturing. Very simple data to analyze, right? And I'm going to select this table, which is manufacturing table, and start analyzing it, right? So I'll select that table, I'll load it into Power BI. It is just a very simple table, so it would be quite easy to analyze. If you have worked with Power BI, you already know it's like a drag and drop environment. Like, for example, I can build a table here. This is not a course about visualization, so I go through this part of visualization very quickly. I create a table here with product, with date, and with costs. That's now my manufacturing data visualized as a table format. I can also bring something like a slicer for date and one slicer for product. So I can actually build whatever report I want, very simple with this, right? And I can put like some beautiful visualizations like column chart, all other types of charts, right? But that's not the purpose of this session, right? So I have this model and it works beautifully. When I select a product, it filters that product. When I select a specific date range, it filters it based on that date range. Everything plays really good here. Now let's go to one step more. Let's say, okay, I have a requirement now that I want to analyze not just the manufacturing data, but also sales data and inventory data. All in one Power BI report, right? So in one Power BI report, I want sales information, which is by product and date, manufacturing information, which is again by product and date, and inventory information, which is by product and date, all analyzed in one report. Like, for example, I want to pick a specific date and see, and a specific product and see, okay, for this product, how much inventory I have in each warehouse. What is the cost of manufacturing for that date, and what is the sales revenue that I got for that product, right? Not in different Power BI report, all in one report, right? It seems simple, right? It's just like two more tables to add, but let's see what is the problem when I do that, right? So I'll go back to my Power BI report. I'll connect to that same data source, which we had the other two tables, and these are the other two tables: inventory, which has information about in this date with this product, in this inventory, in this warehouse, we got this much quantity. And the other one, which is sales, which shows again in this date for this product, this is the quantity of sales and this is the revenue, right? I'm selecting the other two tables, right? So I select all the other two tables and I load it into this model, and Power BI by default applies a relationship, automatic relationship data type. Now, if you are starting Power BI, I would always suggest to turn that feature off. It's one of the options. You can go to Power BI desktop option and turn it off, because when Power BI creates the relationship itself, you have no idea what's going on behind the scene, right? And you might have like 20 tables. You don't know what is related to what and what's going on, right? So I would suggest at the beginning do that. But in this case, it didn't find any relationships, which for some of you might be a little bit surprising, because we have fields that are kind of the same name. Now let me make this bigger so you can see it even much better. Okay, so I have 3 tables. As you see, there are some field names that are like similar, like product. In this one, it's product name, but yeah, at least between these two. Date, we have date in every single table. Now, when I when I bring it, the automatic relationship detection didn't detect that, right? There's a reason for that. I'm going to show you why. For example, if I connect this product to this product as an example, you'll see that the relationship comes up with a specific type of relationship called many-to-many relationship, because the product field that I have in each table has multiple values in it, right? For example, you see this product PN34, which is like twice at least in this view, and this is just a preview of that data. We might have more, and same for the sales table as well. So I have a field that is like repeated multiple times in each of these, right? Now, Power BI supports a many-to-many relationship, but many-to-many relationship is not a recommended relationship to use because it will affect the performance. It is something we call it as a weak relationship. It causes a lot of other challenges as well, right? And it's not always solving the issue, right? So I'm not going to create that relationship. I'm going to cancel it for now. Let's say, okay, product wasn't helpful. Let's say I connect it based on the date, right? So I connect, in this case, the date between these two. That's create a relationship, the date between these two. That's create a relationship, and the dates between these two, right? So then I get the problem of that, okay, all of these relationships are like all different types of relationships. What's going on here, right? Some of them are like solid lines, some of them has like two directions, some of them is like dashed line, right? The reason here is that there are a number of types of relationships. Like the perfect type of relationship is like one-to-many relationship, which filter one table based on another table. When you get one-to-one relationship, it creates both directional relationship, and if you have already a relationship between two tables through another direction, then another relationship creation would make it an inactive relationship, right? So I'm going to remove this inactive relationship. The dashed one is inactive relationship. I'm going to remove that. And I'm going to keep these two. Now, what is the meaning of the direction of relationship? Direction of relationship means that these data will be filtered in both directions, but between these two, it won't be filtered on both directions. It will be only filtered from manufacturing to sales. So if I want, for example, something from the sales table to filter manufacturing table, then I have to change this direction, and the way you change the direction is you double click on the relationship, you change the cross filter direction to both, right? Both directional relationship is not again recommended because it put a significant performance load on the model, especially when you have too many tables. Your tables has a lot of data, right? But I'm going to keep it because I'm going to show you that even a both directional relationship is not giving us what we want, right? In this model right now, you might say this is like a perfect model because every table is related to each other, right? All of these three tables are connected, both directional relationship. It means if I select something from this table, it filters past all the way through, and I can see it in the sales table, or if I select something in the sales table, filter pass through all the way to the inventory table, right? So it might look like a ideal model, but let me show you that this is not. So I'll go back to the report, and this is the report that I already had, right? I'll create a duplicate of this page. And let's say in this page, I just don't want to show the manufacturing only. I want to also show other information. So this is a table for manufacturing. I'll keep that there. I'll create another table for sales details. And I basically show everything in the sales table in it. Right, so this is my sales table. And I create another table for inventory. Date, product, quantity, and warehouse of that inventory, right? So I have all of these three tables. And I also have my slicers. Now, to make it a little bit easier to understand, I change actually my slicer because I have a very small data set. I created this specific data set to show you what happens. So I have a really small data set that has only a few days values in it. So I change it to show the actual list of dates just to show you what happens because I don't have so many dates in it. Usually you don't keep a date slicer like this because you have a lot of date fields in it. But in this case, I don't. right? Okay, so now let me explain what is the challenge, right? So in this slicer, obviously, when I select something, it will filter everything, right? But now here is the problem. So let's look at some of these dates, for example. So the slicer is already sorted. For example, in this table, I have a date which is February 2019, and it is 19th of February, and I don't really see that in the slicer, right? In the slicer, you see I have 10th of February, I have like, then the next day is 3rd of December, right? So I don't really have this date. And I might have something from another table which is not in that as well. Like, for example, in this table, I have 12th of February, which is not in that slicer, right? So there are some dates which is not in this table, right? Now, the way that usually you play with dates is you create like a date table, you put all dates in it, and then that can filter everything, right? But that's not just about the date table, it's also the product table, right? There are products that are not in this list, right? So it's not just a date table, it's almost everything, right? Example, so here I have product 13. And in this slicer, you can see that there is no product 13, right? This is not a complete list. I don't have a master list for my slicers. For your slicers, you need to have a master list. And I don't have a master list for date. I don't have a master list for product. Even though I've created the both directional relationship, which is not recommended by itself already, even after doing all of those, I still have the challenge that this report is not giving me what I want because I don't have the master list, right? And also this both directional relationship will cause a lot of performance issues, right? So this is not a good model. It's not a model that can solve my challenges. Then I end up with like hundreds of calculations to cover this model, right? We call it a bad model, right? This is a bad model because of what? Because there are problems like this. First, it needs many-to-many relationship, right? And many-to-many relationship cause a lot of issues. It needs relationship based on multiple fields. Let me go back to the model one more time. I've created this connection based on date, but these tables should be also related based on the product, right? That relationship is already missing. And I cannot create that relationship because that would be like an inactive relationship. Then I have to switch between these two relationships using a function in text like use relationship and things like that. So this is again not a good practice. So going back to the problems, one problem was many-to-many relationship. Another problem is that I need to create a relationship based on multiple fields. I end up with creating bidirectional or both directional relationship, which is another challenge. And after doing all of those, still it won't solve the issue because then I have to think, okay, which table should I use as a slicer? Because if I bring one of these tables as a slicer, then the problem is that it doesn't include values from the other two tables. I don't have a master list, right? And these are just a few of problems with this model. There are heaps of other problems as well, but this is just only a few, right? Okay, now let's talk about how we can fix it. Or before talking about how we can fix it, let's talk about what are our findings. So our findings from this problem is that you need to have like different types of tables. One type of tables that can be used as slicers, another type of tables that can be used as values, right? And these two types of tables are different, right? These two types of tables should be kind of connected to each other. These two types of tables should be connected in a way that the table that used as a slicer can filter the table that used as a value. So we need to like build a different diagram. We need to build a different data model. We need to work with different concepts of tables, right? So let's talk about that tables and their concepts a little bit more, right? Those tables that you use for slicers, and not just for slicers, but also axis of your charts. Like for example, here in these charts, you see I have the date for axis for one of these. I have yearly income for axis of another thing. These are tables that we call them dimensions. These are tables that keeps descriptive information in it. Descriptive information is not just text, of course. Descriptive information can be date, it can be a number like age, it can be the income of, let's say, employees. It can be all types of things that you want to slice and dice data by that. That is the main purpose of a dimension table. It's used for slicing and dicing. Now, this slicing and dicing sometimes happens through the axis of a chart, through a legend. Sometimes it happens with a filter, with a slicer, something like that, right? As long as it is used for slicing and dicing, it is a descriptive field, and we put it in a table. We call it a dimension table, right? Usually we put all like related stuff of that together in a dimension table, right? Like for example, if you have a product color also comes beside that, product category also comes beside that. These tables are usually wide. By wide, I mean they have a lot of columns. Like in product table, types of columns that you might have is product number, product name, product brand, product color, product category, subcategory, a lot of other stuff, size of product. So you can really build dimension tables with like hundreds of columns. These tables are shallow. They don't have too many rows. Now, you might have a dimension table with 1 million rows, but that is nothing compared to, let's say, your transactional table, which is probably like hundreds of millions of rows, right? So these tables are wide and they are shallow, right? And we call these dimension tables. So if you hear about dimension tables, those are tables that are used for slicing and dicing, right? Examples of dimension tables, what are good examples for that? For example, dim product. Usually we put that dim at the beginning of those because that's, let's say, annotation showing that this is a dimension, like a prefix for that, right? Product is a dimension table, customer is a dimension table, promotion is a dimension table when we talk about a sales scenario, right? On a different scenario, one of these might be a fact table, right? Because it depends on the requirement you design the model, right? Okay, now we know the dimension table. Now let's talk about another type of table. There are some tables which keeps values, and these are values that you use in your charts, in your visualizations, in your line chart, in your table. These tables, we call them fact tables, right? And these values are usually numeric and aggregate tables. Sometimes you want, let's say, the minimum, the maximum, the average, sum, all sorts of aggregations you might want to do in these tables, right? These tables, we call them fact tables. Fact tables are usually very big, I mean, in terms of the number of rows. So these are not shallow at all. These are very deep. You have like hundreds of millions in these tables easily, right? They do not have that many columns on the other hand side. They have a very few number of columns, right? They are not like dimension tables that has hundreds of columns. And then these tables also, in addition to those columns that keep numeric information and values, they also have keys, which is connecting them to their dimension tables, like a key to customer table, a key to the date table, a key to the product table, right? To link between these two, right? We call that like a grain of the fact table, which keeps the level of detail. Sometimes in a fact table, you keep one record per customer. So the grain of that fact table is per customer, one row per customer. Sometimes you keep a record per customer, per day, per product. The grain for that would be per customer, per date, per product. Okay. So that defines the grain. And then how these two relate to each other, you will have one fact table in the center, creating a relationship between that and dimension tables with one-to-many relationships, single directional relationships from the dimension table to the fact table, right? And that also means that the dimension tables now can filter the data in the fact table, and that is usually the ideal way that you want to analyze the data, right? Now, this builds something that in data warehousing terminology or in BI terminology, we call it a star schema, right? Because this fact in the middle is like the heart of the star, and these are points of star. This star schema, I mean, it shouldn't have only like 5 points to say it's a star. It can have like 2 points, 1, 10, whatever points that it has, right? The main thing is that you should have one single relationship between the fact table and each dimension. You should not have two dimensions connected to each other, right? Because of a lot of those, let's say, issues that you might get, right? Now, there are a lot of details about these. I'm just skipping the details and advanced topics. I'm going through only basics at this time, right? A star schema is not just one fact table connected to a number of dimensions. In a model, you can have more than one fact table, and each fact table with the dimensions around it can build a star schema. Like in this model, you see I have two different fact tables, and they still build a proper star schema each because they have connected to dimensions around, right? Like a budget versus actual scenario. You can have your budget table with different granularity, your actual table with different granularity connections to the dimension tables, right? So a star schema is not just one fact table. When I talk about that, a lot of people comes and say, okay, I have more than one fact table, so how can I build that, right? So it is possible. Okay, now that you learned about two different types of tables, you learned about relationships between those, and you learned that this is called the star schema, and that's the best practice for modeling. Let's talk about why star schema is the key thing, right? Consider an orchestra. In an orchestra, everyone can play their own music, right? And they can play it even without a conductor. But without a conductor, no harmony, they won't talk with each other, you hear music which is not good, with a good conductor, it would have been really fantastic music, right? The star schema for your data model is like a good conductor. It's a good conductor that makes sure that everything plays with each other really nicely, everything answers the requirement, right? And building a good star schema takes a lot of time, right? There are like books on this topic. There are like courses on this topic, right? I'm just showing you that through the example that you have seen in this session, that how I can apply that star schema, and then it solved my challenge, right? Okay, so let's go back to the model, and let's see now that based on what you learned so far, how we can fix it, right? Okay, my model needs different types of tables, right? You learned that there are tables that used for slicing and dicing. Those are tables
Reza?
that yes.
We don't see the we don't see Power BI.
Oh, I haven't opened Power BI yet.
Oh,
Let me.
sorry about that. Didn't mean to rush that.
No, that's okay. Do you see it now?
Yes, I do.
Power BI.
Yes, yes, I do.
Oh, okay, great. Okay, so going back to this, let's say, example that I had. So I have a number of tables here. Usually the first point for you to understand what dimensions you need is to look at your slicers and places that you use as filters and axes and things like that. So in this model, it's pretty simple that I have like two slicers, one slicer for date, one slicer for product, and they are not, of course, related to each other. Like if I had a slicer for product, another slicer for product color, I could have combined those into one table. But in this case, date and product are not related to each other at all. So I need two dimensions here. One dimension for the date and one dimension for the product, right? And then these two dimensions should be connected to those data, and those data in other tables can be my fact table, like the quantity here, the cost there, and these can filter those, right? So my approach should be building something like this model, right? Something like this, that I have my sales, inventory, manufacturing tables, like fact tables, and then date and product like dimensions, but of course shared dimensions. We call it shared dimensions because multiple fact tables are connected to this shared dimensions, and these can filter all of these three tables, right? So with usage of star schema, I can build this. This is a much better model. It will answer all questions that I have, right? So let's first build it, and then I'll show you what are the benefits of this, right? Now, building a model like this requires some understanding of how Power Query works in my scenario, because I'm using Power Query for data transformation. Some of you might use SQL Server for data transformations, some other tools for data transformations. Because we are talking about Power BI, and Power BI tool for data transformation is Power Query, so let's do that in there, right? It is also possible to do this with like DAX calculated tables, but then the problem is that you will probably need some intermediate calculations, and that is extra load. If we do it in Power Query, we put that load before the refresh time, and we can hide those tables and remove those tables that we don't need, right? Okay, so I go to Power Query with just simple click on Edit Queries. This brings Power Query Editor up here. Now I have these three tables: manufacturing, sales, inventory, and they each have product column in it. Now let's say I want to build a product table. So if I want to build a product table which has all the products in it, I have to actually build a consolidated list of all these products, and then remove all duplicates. That would be my product table, right? Now, to do that, there are different ways. One way I'm showing to you here is I'm not going to change these three tables. I'm creating a reference from each table. Reference in Power Query means that whatever that query is, I'm creating a new query that points to that query. If that query changes, this query will also change, right? So I'm creating a reference of this. You see it's inventory 2, and in this reference, I'm removing everything, only keeping product column with something like this, remove other columns, right? So that would be my product column only. And this is not affecting my inventory table, because this is a reference table from that table. My inventory table is still proper. It has everything that I need in it, right? So I'll go back to my inventory 2 table. So this is everything removed, only product. Now I'll do this for the other tables as well. For the sales table, reference, remove everything and keep only product name. For manufacturing table, reference, remove everything except product, right? So I have now 3 tables here that has only 1 columns with product, and I'm going to like consolidate them together. A way that we use in Power BI or Power Query to consolidate the list is using append, right? Now, before using append, you see this column is called product in this table, product in the inventory table, but it's not called product in the sales table. It's called product name. So let me rename that and make that also a product, because append plays much nicer when you have all columns similar, right? If it is not, then you have to put like conditional column afterwards and then combine them together, which is a little bit extra work. So I rename that and I make sure this is product in every one of these. And then I want to combine these and build a, let's say, master list, right? To combine tables in Power BI, there are different ways. One way of combining tables in Power BI is what we call append. And you can see it actually in the Home tab in Power Query under Combine, Append. Append queries means that you have tables with the same structure but different rows, and you want to append rows to each other, right? So I'll go append rows, append queries, sorry. Append queries as new. And as new means that these queries will be there. I will create a new query, which would be the result of appending of all of those. In my case, I have 3 or more tables. I'll select those. Manufacturing is one of my tables. I'll bring also sales table. I'll bring inventory, right? And I get those that are like number 2, because those are the one that has only 1 product column in it. I don't care about the other columns in this tables for this master list of products, right? I select everything that I need. If you have like tens of tables, you create, you combine them all like this, right? When I click OK, it creates a list with all products in it, right? From all of the 3 tables, right? I'm going to call this product, right? You can also call it dim product because this is like your dimensions and things like that, but I'll keep it product. That makes it much easier to understand. Now, after building this product table, I don't really need the other three tables here, right? Because I have my actual main three tables here. So these are my tables, let's call it fact tables. These are my fact tables. This is my dimension table. These tables are like some intermediate tables. I used to build the actual product table. I don't really need them. And if I'm going to remove them, the problem is that it won't allow me to remove it. So if I right click on one of these and say, okay, remove or delete, it tells me that I cannot delete it because it is referenced in other places. So if I don't delete them, then problem is that when I say close and apply, these tables would be also loaded into Power BI. It probably cause creation of some extra relationships. And also on the other hand side, these are tables that I don't need at all. So why loading them into Power BI, right? And the good thing about Power Query is that you have the option to say you do not want some of the tables to be loaded. And you get that option when you right click on a query. The option is called enable load, right? If you say I don't want this table, you just uncheck the enable load, and that table will not be loaded into the Power BI. It is still part of your Power Query. It's not going to be loaded into Power BI. And I know you will ask this question as well, that what if I refresh the data? If you refresh the data, this table, even if it is not enabled load, still is part of your refresh. It is just not loading individually. Still, it's part of the refresh. The data will refresh, will come to the inventory, then inventory 2, then it goes to the product table. So it will be all perfectly fine. It's just not loading individually, right? So I'm going to right click on these tables one by one and uncheck the enable load. Unfortunately, we can't do that multiple tables at a time. Hopefully it will be added into Power BI for some time. I'm also usually a good fan of like putting these in a group. So I'm creating a group here. I can call these like intermediate tables, and I move these in there, right? It's like creating a folder. It makes your Power Query solution much more cleaner, right? I can also
never thought of that, Reza. That is pretty smart. Putting it in a group.
Thank you. Thank you. Yeah, it's really powerful and useful. I'm also putting my product table in another group, let's say dimensions. You can also put descriptions, which would be helpful, and everything else I move them to, let's say, something like fact table, something like that, right? I mean, building your grouping is up to you. You have all different, let's say, standards that you can follow, but I always recommend having groups because it will make your solution much more tidy and nice. Okay, so I've got my product table. It has all the products in it. Those intermediate tables are not going to be loaded into Power BI anymore, so that's fine. But there is one thing more. The product table has multiple, has duplicate entries because, for example, showing some like product number 10. It probably wasn't duplicate in the source, or it might be even duplicate in the source. But because I'm getting it from different tables, it's going to be duplicated because you might have one product across multiple tables anyway, right? So we have to remove these. Dimensions should not have duplicate entries for the key field. In this dimension, I don't have any other fields. I mean, later on I can add other fields, but at the moment this is the only field that I have, and this is the key field. So it's good to remove duplicate. Now, when you remove duplicate, it's always a good idea to, especially when it is a text field, it's always a good idea to make sure there is no spaces before and after. Transform trim would make sure of that there is no space before and after. Power Query is a case-sensitive language, so it's always a good idea to change them all to uppercase or lowercase before removing duplicates, because PN, capital PN, lowercase are two different things, right? In my case, everything is capital already, so I'm not going to do that. But if you are doing that, remove duplicates on a text field, make sure you take care of that. I have written an article about this, that what might happen if you don't do that. Okay, and then at the end I say remove rows, remove duplicates, right? So this is my dimension for the product. It has only a unique list of products, and this is what I'm going to use to create the relationship, right? So let's say close and apply. Now going back to my model, Power BI automatically detects some of these relationships, right? I have to remove those relationships that are not necessary anymore. In the world of star schema, we don't connect fact tables to each other. So I'm going to remove these both directional relationship between fact tables, right? Now I have the relationship between product and manufacturing. Between product and inventory, it's inactive. I double click on it and make it active. And between product and sales, I connect it as well. And that is single directional relationship from product table to every one of these, let's say, fact tables. Now, that product table is something that I can use in my slicer for product. Rather than getting the product from manufacturing, I use the product from that table. And this is also one of the practices. After creating these relationships, you have to hide the field in the relationship in the fact table, right? For example, product here, I'm going to hide it in report view, or the product here, I'm going to hide it in report view, and the product name here, right? Because these are like technical for me to create the relationship. These are not for user to use, right? User should be using only that product field. Now I'm going back to my report, and instead of this product, now if I search product, I should have it only in one table. Yep, here it is. And I'll bring that in my slice, right? You see I have all products here, which if I select any of these, it will filter all tables that has these. Obviously, I mean, one of these might exist in some of the tables, might not exist in some others, right? But I have a master list here that will filter everything, right? Now, this happened at the product, but not about the date, right? I still have the issue that date is not a full list, date is not all the values that I want to be, right? You should also have a date table, right? Now, there are like heaps of different ways that you can create date table. Some people create date table in Power BI using functions in DAX, like calendar table or calendar auto, things like that, which is fine. Some people have their own date table built in SQL Server. They use that. Some people build it in Power Query. I'm more fan of the Power Query way of creating the date table. The reason is that when you do that in Power Query, you can also bring public holidays and things like that in case you want to analyze some data based on that. Now, I'm not going to build a full date dimension now that has all of these, but just showing you how easy it is to create a date dimension in Power Query. I have like a couple of videos on that case. You can watch it in Reza Rad YouTube channel. Okay, so let's go and create a date dimension. For the date dimension, I'm creating a new query, a new blank query. And I'm doing it, I mean, quite fast because this is not something that I'm going to talk about in this session, how to build the date dimension. That takes a little bit time itself, right? So one of the ways that I can do that is I can start with this. I can say list.dates, and that will give me a list of dates. I need a start date and an end date, and usually, and a start date and the duration. So usually you define dates like this, hashtag date, and then let's say I start from 2019, 1/1, and let's say I want to do it for 1 year. So let's say 365 days. That's how many times I want to do that, and duration of 1 day at a time, 0 hours, 0 minutes, 0 seconds. Again, I'm not explaining the details of this because this, I mean, takes time itself. It's more like about Power Query functions, how this works. But what it does, it will give me a list like that, right? List of all dates, right? Then I can convert it to table. That becomes a table. I can call it date field. I can set it also as a data type. Now I can add columns to this for year, month, and quarter, and everything like that. And that would be as easy as this. I can click on this column, then I go to add column, date, year, year. That would be my year column. Then again, selecting the date, month, month. That would be my month number. Again, doing this time, name of month, right? Doing it again, quarter of year. Doing it again, this time I get, let's say, day, which is day of month, right? You can get every one of these that you want. I'm just selecting a few, but you get the point how easy it is to build a date dimension. It's not really a hard job to build a date dimension, right? Anyway, let's say this is my date dimension. Let's call it date, right? So I have my date dimension. I have all other things here as well, like product dimension. So these are my 2 dimensions, and these are my fact tables, right? Now that I have this date field build, date table build, I close and apply, and then go to the relationship, and then creating the relationship. So this would be date to date, date to date. If this creates a both directional relationship, make sure set it as single directional, because sometimes when it is one-to-one, Power BI automatically makes it both directional relationship, and then it would cause creating like a circular difference sometimes, and then the result would be that this doesn't really allow you to create all active relationships. So from date to inventory, it would be one-to-many, and it would be single. That's why it's a good idea to create those relationships one by one yourself, to have an idea that how this is going to work. So one-to-many, single, active. And then the last one, where's my date field? Over here. And that's one-to-many. So you see that I have like one-to-many relationship from date to every one of these fact tables, from product also to every one of these fact tables. So this is like a perfect star schema, right? In my star schema, every fact table has only like 2 points, 2 dimensions, but still fine, right? And I have like 3 stars considering it here. Now let's go back to my model. Oh, one thing that I forgot, we also have to hide the date in these tables, because it will be confusing then if we keep the date over there. So I hide the date. You see there is no date over there. So these tables only have their quantities and things like that. You see some of these still need another dimension, like warehouse here should be again another dimension. But let's not talk about that. That's a different scenario. Okay, now going back to my report. I find the date table, and one good practice is also, if you are not using the built-in date table and using your own date table, to make sure go to the modeling and mark it as your date table, which I'm going to do that. It asks for a date field, which is this field, and that's it. Now in this slicer, I'll bring my date field as a slicer, and you of course see all the dates here, right? Now that I have all the dates, so I'm going to change it to be like a between a slicer, because that would make more sense. And this will filter everything. Now this has all the dates in it. This one has all the products in it, right? So I have actually 2 slicers, which are like master list. They will filter everything in these 3 tables with a model which is fully a star schema build. Using just Power BI, just Power Query in Power BI, doing some transformations. Now, going back to my slides, what is the benefit of this model compared to the model that you have seen before? In the model you have seen before, we had no master list. Here we have a master list, which we call it actually shared dimension, right? I don't really need many-to-many relationships. I don't need both directional relationship. Performance of this model is super fast, right? I have a clean design of my fact tables, which keeps actually the transactional data or the values, and my dimension tables, which are used for slicers, for axes, for anything about the slicing and dicing. Everything is single directional relationship, one-to-many relationship, and this is a perfect star schema design, right? Converting a bad data model to a good data model with that. Now, talking about like building a data model is not always as simple as this. Your real world scenarios might have more tables in it. It might be a little bit more complicated. And you have to spend time to build that. Like another example, which I'm not going to explain because it takes, again, another session itself, is I'm pointing you to that direction. Like, let's say, what if you have fact tables, but they are not on the same granularity? Because in that scenario that we had, our tables were in the same granularity. They've been all by date and product. But what if one of your tables is not by date, it's by month or by quarter, and the other table is by date, like a actual versus budget scenario? One of them is like budget is monthly, actual is like daily, like totally different scenario. Can you still build a star schema with that? Yep, I have written an article just like this week about that, how you can build it. You won't even need like complex calculations or both directional relationship. It works perfectly fine. I encourage you to go and read that. That article is free, available in your website already.
Reza,
okay. Yes.
we have a question, but before we have a question, I want to comment on that, and I want to see what your response is. So in this scenario, which I come across a lot working with financial numbers, I usually, in like the budget one, which only has the month, I will usually put in like the last day of the month. Is that something similar to what you
exactly? Yes, that is the way that we do, either the last day of the month or the first day of the month, and then we connect it to that date shared dimension, and then it would play really nicely.
Cool. Okay, and then here's a question. What about when you have a table that has more than one date value? For example, a created date and a closed date. If cases in FSDC, wouldn't I need the date table to be related to both dates at the same table?
Very good question. So this is a scenario that we call it in data warehousing terminology. We call it actually a role-playing dimension. You have a date dimension, but that date dimension sometimes it's created date, sometimes it's closed date, sometimes it's a start date, sometimes it's due date, order date, all sorts of things, right? What you need to do is to connect that date dimension to every one of those. Now, the thing is that if you want to create multiple connections from that date table to that, let's say, fact table, then the problem is that it won't allow you to create the second relationship, the third relationship. I mean, they will be like inactive relationship. So you have two options. One of your options would be like creating role-playing dimensions, which is like copying the date dimension, copies of the date dimension. You can do that copy in the Power Query, or you can do that copy with DAX with calculator tables, which is usually the way that I do it in DAX calculator tables, and then create active relationship between those. Power BI automatically create a date table. So if you have a date field, Power BI automatically create a date table behind the scene for every one of those date fields that you have, which is like actually that role-playing scenario that I explained, right? Sometimes that scenario might be good, sometimes might not. And that has its own explanation that would it be better to use the Power BI default date table for these scenarios, or you create your own table? I would say, yeah, better probably to go and check that article, because it's a long list of things that what you gain with the Power BI default date table, what you gain with your own custom date table, and what are the scenarios. But building it is like what I mentioned, creating role-playing scenarios. Keeping inactive relationship and then using the DAX function of use relationship is also an option. If you want to analyze everything in one chart, then that would be an advice option. Okay, so cool. Let's continue. It's almost closing it. So this budget versus actual, I'm not explaining it, but I have written an article about that. Make sure to go and check it out. Now, for closing it, then I'll check if there is any more questions. I'm doing a lot of Power BI trainings. You can go to Radicat website and check out our trainings. We do like video trainings and also in-person trainings. As Belinda mentioned, a little bit later this year, we'll be in the Orlando for some training courses there, and also the summit. all of these examples that I explained to you, I have written articles about every one of these, and there's a link for these. I put these links in the same YouTube page that we have, so you can access all of these. These are all free, available for you to read and further studies. There are even more examples that I haven't explained there. Okay, that's pretty much me. Any more questions we got?
Well, there was just a couple responses. Someone responded to that same question, that Reza's response is right on, but it depends entirely on your use case to attack the reporting requirements. And then the original person who asked the question wrote, I have that function turned off after reading your article, especially in the new version of the desktop. I think the function might be the date function that he turned off. Yeah.
Yeah, I think the default date function. Yes, correct. Yes.
Right.
Yeah, yeah, exactly as mentioned. Building a proper model is building it based on a requirement. Sometimes based on the requirement, I might keep the default date table. Sometimes based on the requirement, I might create my own date table. Sometimes I might create inactive relationship and use the use relationship tags function. Sometimes I might do differently. Sometimes I might have a dimension for product. Sometimes I might have a fact table for product because I'm analyzing something as part of the product itself, right? So it all depends on the requirement.
Right, and DAX can call those inactive relationships too if you end up having an inactive relationship on something. I just thought I would throw that out there as well.
Exactly, yeah, with the use relationship, yep.
Right, and so, wow, that was really great. I picked up on quite a few things. You got my creative juices flowing, so how lucky are we that the fabulous Reza Rad spoke at our group. Hot diggity dog. Thank you so much, Reza. I cannot thank you enough. I am smiling from ear to ear. You made my whole week. Yay! And a special shout out.
I really appreciate the opportunity.
And a special shout out to my co-chapter leaders, Retta Shofani and Rhett Stifer. You guys rock it too. All right, everybody, thank you. Don't forget, this is going to be on YouTube, and you guys are watching it there. You got the link, so feel free to go back and watch it again. I have a feeling I'm going to. So thank you, everybody, and I look forward to seeing you guys next month. And as people are saying on the screen, great session, and thank you, Reza. Enjoyed this greatly. I did too. That was coming from somebody else in our group, but I really did too. Everyone, you have a wonderful day, and for those of you in Charleston, stay dry. It's raining outside. All right, good night, everybody.
Thank you, everyone, for joining. Cheers.